Hi everyone. So what we're going to be working on right now is more right triangle trig, but we're using the right triangle trig to calculate angle measures. And in order to calculate angles, we will have to use the inverse function on our calculator. So what we're giving you here is that the cosine of theta equals 4 over 5. And what we're asking for is, well, what is the angle that makes a right triangle have a cosine of 4 over 5? Essentially, what we have to do is undo taking the cosine. So what we will do is we will take the inverse cosine, which we write like this. And we'll take that of each side. So I'm add a space over here, so I'll just write it over here. What happens with that is the inverse cosine and the cosine cancel each other out. They're inverses of each other. They undo each other. So what it's done is it's isolated theta for us. And theta is equal to the inverse cosine of 4 over 5. Now, this is a straight calculator problem. What you're going to do in your calculator is you're going to make sure you're in degrees. So you'll go to mode and make sure you're in degree mode. And then you'll tab out of that and you will hit second and the cosine button. What should come up on your screen is this: cosine to the -1 with a parenthesis. And all you do is put 4 divided by 5 and hit enter. Your calculator should tell you that this is a 36.9 degree angle. Okay, so it's as easy as that. So for letter B, we're told that the tangent of an angle is 7 over 24. So to undo that, we will take the inverse tan of each side. That's tangent to the -1. That's how we write that. So tangent and inverse tan cancel each other out. And what we get is that the angle equals the inverse tan of 7 over 24. Now make sure you check that in your calculator. You should get 16.3 degrees. Okay? And the last problem, we have the sine of theta equals 4 over 5. Calculate sine. So we will take the inverse sine of each side. Just like how you would take a square root of each side, or you'd square each side. So we're taking the inverse sine of each side. We rewrite it like this. And then we put that in our calculator, second sine of 4 over 5. And you should find out that the angle is a 53.1 degree angle. Okay, so it's pretty simple, pretty much like I said, a calculator activity. If you look at example 2 here, it's really the same kind of problem. The only difference is we're giving you a diagram. So I'm asking you to calculate the measure of angle A. So angle A is right here. From that vantage point, we have to label the sides. So the side labeled 4 is our adjacent. We know this side right here is our hypotenuse, but we don't need that. The side over here is the opposite side. So I guess the challenge for this is that you have to figure out which trig ratio uses opposite and adjacent. Well, of course, it's tangent. So we have that the tangent of angle A is equal to opposite over adjacent, so 10 over 4. And now we know we have to undo taking the tangent of that angle. So we will take the inverse tan of that angle and that side. Both sides, I shouldn't say the angle, of both sides. These cancel each other out, and we're left with angle A equals inverse tan of 10 over 4. If you wanted, you could reduce that to 5 over 2. It really doesn't matter. Your calculator is going to give you the same answer. And we find that the measure of angle A is 68.2 degrees. And we tend to round to the 10th for angles, so just keep that as kind of a standard rule. Okay, letter B, very much the same problem. We're working from this angle. We can clearly see that the 27 is our hypotenuse. And this 15 is attached over here, so that must be our adjacent side. Which trig ratio uses opposite and adjacent? I'm sorry, which trig ratio uses adjacent and hypotenuse? It's cosine. So we have the cosine of our angle, which is theta, equals adjacent over hypotenuse, 15 over 27. Again, we will take the inverse. In this case, we're taking the inverse cosine of each side. These will cancel each other out, and we're left with theta equals inverse cosine of 15 over 27. Again, you could reduce that if you wanted to, but I wouldn't bother. And we would find out that we have a 56.3 degree angle. Now, you want to make sure you're getting those right in your calculator because you're going to have to do the rest of the problems on your own. Okay, so make sure you're getting those right. Have a great day.